Hi guys, my name is Danny Zuniga. I'm part of Challenge 2014. That's my friend Jasmine. I'm chilling in my room, doing videos, really late. Alright, so today's problem, we're finding the volume of a solid that's rotated. So it's a two-dimensional shape here, rotated about the x-axis is what was asked for. So the two-dimensional area is modeled by the function x equals y minus 2 squared, and then you're asked to rotate that about the x-axis and give the volume of the generated solid. So in order to do that, you're going to use the shell method, and the reason is that the function is in terms of y and you're rotating about the x-axis. So in order to not have to manipulate this function to get it in terms of x, you can just use the shell method, and you can use the shell method and have both of these different. So what the shell method is it says 2 pi times the integral of the radius times the function. So our radius is going to be y, because if you look here, y is really our radius. If you picture rotating the solid, this is our radius, y at any given point. And then y minus 2 is our function. Y minus 2 squared is our function. So then after that, what's left is just expanding and integrating. So as you see here, we expanded, so that y minus 2, all I did is expand it right here. So now it's y squared minus 4y plus 4. And then you still have that y outside, so you distribute that into each term. And now we have y cubed minus 4y squared plus 4y there. And then we can take the integral. So when we take the integral, we're going to add a power and divide by that power. So y to the fourth divided by the 4. Negative 4/3. Negative 4y squared becomes negative 4y cubed over 3, because we divide by the power again. And then 4y becomes 2y squared, because it's 4y squared over 2, and I just reduced that to 2. And now we gotta remember that our boundary was set by the graph up here. So I hadn't addressed the boundary, but I had written it here, because if you draw this graph, it looks like this. And you just, since it says that the area is bounded by the x-axis, the y-axis, and this function, we know that it's going to be this right here, and that all intersects through this area here. So it, in terms of y, that's going to be 0 to 2 up here, as you can see with the graph. So now we evaluate for those two numbers, so 0 to 2, into the function we just integrated. So we plug in the 2, and you don't really have to do this whole minus 0 at the end, because putting in 0 is not going to change anything. So we just put in 2 to each, so that's what I did on this step. And then with a few basic steps of algebra, so here what I did was, it's 2 to the 4th is 16 divided by 4 is 4. Then here 2 to the 3rd is 8, so 8 times 4 is negative 32 over 3. And then this is the same as 2 to the 3rd, because it's 2 times 2 squared, so it's 8. And then we get 4 and 8 make 12, which is also 36 over 3, if you want to get common denominators to add, or subtract in this case. And then you get 2 pi times 4/3, and that becomes 8 pi over 3, which is the answer to the volume of the solid generated when rotating this function about the x-axis.